The remainder of the video series will now just be on explaining why the interior setup moves worked. It is definitely a step up in difficulty compared to what we've done before. In general, if we insert interior setup moves A and invert it after the algorithm piece 3B prime 3R prime 3B, there are limitations on how the setup moves A affect the cube. If we ignore the limitations of these interior setup moves, we will maybe not totally scramble the cube, but we will certainly discolor more centerpieces as the smallest consequence by not taking the restriction seriously. The most strict restriction we can have on setup moves A is that they do not affect any pieces which are affected by this algorithm piece. If we execute this algorithm piece onto a solved 6x6x6 supercube, we can see which pieces they affect. The portions of the cube which are not solved at the moment are the pieces in the range of that algorithm piece. But this is not exactly what we want to visualize as not affecting. So, if I apply the first portion of the algorithm onto the cube again, next I eliminate all of the pieces in those positions from this point in the algorithm, then we have a much better picture of the pieces we cannot affect from this portion of the algorithm where we're inserting moves. But this has no meaning, because if we applied all the interior setup moves we wanted, we would not correct anything more beyond this right here. So what we need to do is also include another piece to make the restriction not as strict and also make it possible for us to correct this. That piece right there. So now the restriction goes down to this, that we can affect all of the pieces on the cube except for the ones that are missing. And to believe it or not, there is actually one more restriction adjustment that we can make for an exception to this general rule. And that is, this centerpiece right here may also be affected by interior setup moves A, as long as in the process of putting a red piece here, which is our goal for the interior setup moves to begin with, we also put another red piece in this location as well. However, there is also one other thing to mention before I explain this exception. And that is, if we apply the first portion of the algorithm to the cube again, take note of the other piece which is involved with the overall swap of the algorithm. This centerpiece right here is the one that swaps with the one that we identified back here. Because we can put a red centerpiece here, so that red will swap with red, the question we need to ask ourselves is, can we put a black piece down here, and so that this black piece will swap with that one? Well, and the overall effect of the algorithm, these two pieces swap, but not within this piece alone. Because if we go ahead and execute 3b prime, 3r prime, 3b, we'll find something different. 3b prime, 3r prime, 3b. Yes, a red piece came there, and that was that red piece originally in this slot. But now look, a yellow piece is there instead. If we took a black piece and we substitute it here so that that black piece would come here, that would be fine. That black piece from here would go there. We would have a problem, because now we'll have a black piece here when we move it back, and so black will be with yellow, which won't be good. You insert something here, and you undo it there. This should lead us into the question, why are we even allowed to do interior setup moves to begin with? What justifies us to insert a red piece in the back where we have before with 2r prime. Applying the first portion of the algorithm to the cube once again. Take note now of what happens with 3b prime, 3r prime, 3b. The only reason that we're allowed to is because 3b prime, 3r prime, 3b, a red piece is moved here by the algorithm piece 3b prime, 3r prime, 3b to begin with. That is the only reason why we are allowed to do a setup move 2r prime, to substitute a red piece here, and so that we can make an algorithm which does not discolor centers anymore. And so therefore, the exception to just having all the pieces you see disappear from this point, that this piece may also be affected, is because of this fact. Both of these pieces are inevitably replaced by red from down there, by the algorithm piece 3b prime, 3r prime, 3b. And because of that fact, this piece may be affected just as legitimately as this piece. If we undo that now. The thing to differentiate between these two pieces is that this piece is one of the two center pieces which is discolored by the overall algorithm without any move insertions at all. This piece right here, well, if we rotate the cube like this, we can see that if we were imagining that this was black and this was red, this piece right here is that piece, and if we apply the original algorithm without the interior setup moves, notice what happens to it. That center piece will move here, and this center piece will move here. So that center piece is involved in the swap, but at the same time, it is not discolored like the other center piece, which was originally here, which is the one we're comparing it to. And so, because it's not discolored, even though it is affected, if we apply interior setup moves A, and it does affect this piece, we need to simultaneously put another red piece in this location. And of course, we're not allowed to grab these two red pieces down here because these two red pieces are in the restriction that we cannot touch to begin with. I will give an example for that later, but first I want to give a few examples which just illustrate affecting this piece, making it red, just like we did originally with 2r prime, but not affecting any of the other pieces, which are now missing. Just this case. I'm going to apply a few of them, but then I'll go into that exception. As we've done already, just by illustrating how we cannot violate restriction and still have interior setup moves, we can start out with a center commutator with its own setup moves. This is definitely not the shortest route we can take, but we don't affect more than 3 center pieces with it, so we definitely don't have to worry too much about affecting the pieces in the restriction. Let's execute the first portion of the algorithm, and now let's execute each of these interior setup moves one by one to see what's happening. X prime and Y prime is just to position the cube in a way that we can execute a center commutator the way we have at the very beginning of the video. It's no different than the center commutator we've already seen at the beginning. It's just now we're applying it to different slices and for different purposes. And in addition, we're going to have to apply a few setup moves before we do the center commutator to affect the pieces we desire. The first move, after we do those cube rotations, is F prime. That will put this red piece in line with the piece here, which we need to substitute with red. Now, since they're lined up, we can take a center commutator and move this piece and move it there, and then that piece will come here, and then that piece will come here. We can also go in the other direction so that this piece will go there, which is what we want. We're going to put a red piece there, and then this piece would come down here, and then this piece would come up there. But for illustrative purposes and to really test the validity of the restriction, I'm going to choose to go to the left instead of to the right. If we did execute the center commutator, which is this, from this point, ignoring the setup move 2L, what's going to happen is something we don't want. We move that up so that red piece is there, we move it over, and execute the center commutator. And then we can invert F. Look what happened. If we rotate the cube back this way, this is the original starting position. And remember our restriction, what pieces we couldn't affect. All of the pieces which are missing. And if we rotate the cube back this way, look what happened. This piece right here should be missing. If we didn't violate the restriction, this piece right here should be missing as well. So that means that we involved a piece that was missing. And in fact, if we make the cube full again, this piece was originally orange before we did interior setup moves to begin with. And this is one of the pieces we cannot affect, so if we execute the first portion of the algorithm again, as well as x prime and y prime, as well as f prime, just resuming back, this is that orange piece. So we're going to have to do an extra setup move, and I'm going to do 2L, following this example, so that an alternate piece is here, and in this case it's a red. By doing that, and executing the center commutator, inverting those two setup moves, now 2L prime and F, as well as the cube rotations Y and X to help position the cube for us, we have successfully substituted a red piece here without affecting any of the pieces in the restriction. So we can safely substitute this into the algorithm here and invert it afterwards here, applying all of this to the cube. And so it makes an algorithm which does not discolor the center pieces any longer, which is our ultimate goal. So we have one path, but let's just go back very quickly because I don't want us to misunderstand the move restriction. We have to be very careful if we really want to understand this. Take note that after I executed the first portion of the algorithm, I did the interior setup moves which start out with x prime, y prime, as well as f prime. Notice that 2L put a red piece here. So this red went to this black, that black came to this red, and that red came here. Because the two center pieces which are discolored by the overall effect of the algorithm without any interior setup moves to begin with, it is kind of confusing for us to choose red as a choice of a piece to swap with that follows the restriction. This piece does not have to be red. Instead of doing 2L, we can undo it, and how about we just do 2L2 to involve an orange piece, which is unquestionably not involved in the swap to begin with. Now we can go ahead and execute the center commutator to swap those three center pieces. And we can undo those setup moves, as well as execute the rest of the algorithm. And indeed, it is an algorithm which does not discolor any center pieces any longer. The second path that I would like to introduce to place the red piece at the intersection of slices 2R and 3U in B is this following piece. If we execute the first portion of the algorithm to the cube again, and now to help us out visualize things, we can also make all the pieces void which we cannot affect. Now let's handle each of these moves one at a time and try to understand them. They all consist of the setup move A, which we do before the algorithm piece 3B prime 3R prime 3B. Our goal at this point is to put this 1x4 block into the slot right here, where this 1x4 block we put originally by 2R prime, which was the shortest path and made the Holy Grail. So this part right here is what we want to do. We want to bring this there, and this is one way to do it. This path says to move this 1x4 block and move it over here then move this, and then move it twice to put it back there. That's the idea of this, but that's not exactly what the setup moves to do it are, because we have a restriction we need to follow. So instead, we first need to do, because we do want to move this slice down like so, we don't want to destroy the piece right here, which is in the restriction, to do that. Therefore, the first move we do is F prime. We may use F if we wish, it doesn't make a difference as long as we get this piece out of the way. Now we can do that move to U prime to move that 1x4 block there. Next, we do F to move that 1x4 block there, which was our original goal, and now we can do 2R2 to put it back there so that the red piece is at the intersection of slices 2R and 3U and B. And we have not affected any pieces in the restriction. Substituting this into the algorithm here and inverting it here and applying the entire algorithm to a cube, we can see that we have an algorithm which, again, does not discolor the center pieces any longer. The next path is a way of moving the same 1x4 block of red pieces into the same location. And just a quick note, the 1x4 block itself is not required to put the entire thing into that slot, but if we choose to move that 1x4 block, we can definitely not need that many moves to put a red piece at the intersection between slices 2R and 3U and B. Handling this one piece at a time, we execute the first portion of the algorithm to the cube, and now erase all the pieces which we cannot affect just to help us visualize. If we go here, now instead of moving this to the front and moving it here and then doing it twice to get that 1x4 block there, instead we can just move this and put it there to begin with and move it back. But that's not what these setup moves are, because we still have a restriction we need to follow. So instead, what we need to do is not affect this piece. So the first thing we can do is F prime, or F, it doesn't matter, as long as we get this piece right here out of the way. And at the same time, now, after we execute F prime, we execute B, because that piece is to open the path to put this 1x4 block into that portion right here so that a red piece is here, which is our ultimate destination. Now we can go ahead and do the slice turn and undo those two moves, F prime and B, with B prime F. As you can see at this point, all of the setup moves are executed and a red piece is here and no other pieces in the restriction are affected. So we can substitute this into the algorithm and invert it after the algorithm piece 3B prime 3R prime 3B, and applying this entire algorithm to a solved cube. Again, we have an algorithm which does not discolor any center pieces whatsoever. So those were some examples illustrating how we can place a red center piece here without affecting any of the missing pieces which you see by the restriction. And at the same time, we don't even consider the exception to the rule. But now I'm going to give an example which shows the exception to the rule, this piece right here, by taking the following route. If I fill up the cube from this point, I can execute these interior setup moves which do involve that piece. Starting from the original position from which we applied the first piece of the algorithm to the cube, if we rotate it again so that now the target location is in this view, this is the target piece where we want to place a red. So what we can do is we can focus on trying to place this red piece there. So what we first can do is just get it out, rotate the top, now put it in place, and then rotate the top back. So now a red piece has replaced the red piece that was there, as well as replaced the black piece was there. The nature of these two pieces, as I mentioned earlier, are completely different, but we have something that gives us an algorithm that doesn't discolor centers and illustrates the one exception to the general rule. And again, the reason this was the exception is because these two red pieces here will be moved here inevitably by the algorithm piece 3b prime 3r prime 3b to begin with. Applying all this to a solved supercube, it illustrates the one exception to the rule. It helps us understand why we have the restriction we do, and it also, obviously, does not discolor any centerpieces. One final path we can take, merely to place a red piece here without affecting this piece at all, is just to do a variation of the previous path which showed the exception. Instead, if we only move one inner slice, then we have the result that we need. With the cube starting position here, if we rotate it like this, we can see our target location. Now, we want to place this piece there. So all we have to do is move that down, move the top that way, move it back, and move the top back. So now that piece is there, and we did not violate the restriction once again. So we shouldn't have any problem substituting that piece here and inverting it here and applying this entire algorithm to a solved cube to have this, which is a different way of swapping the red, but it is yet another path we can take. We should be able to see why we were allowed to do the interior set move 2r prime and then invert it after 3b prime 3r prime 3b and not scramble the cube, and also, in addition, fix it. Simply because when we applied the restriction to the cube after that first portion of the algorithm was applied to the cube, and in fact 2r prime moved only that piece in the range of 3b prime 3r prime 3b. It didn't touch any of the pieces that are currently missing. What else can we learn from this besides understanding how the interior setup moves for the Holy Grail worked and they didn't scramble the cube but fixed the problem? If we carefully define the characteristics of this algorithm, which could use interior setup moves to fix the two center pieces which were discolored, then we can apply interior setup moves to other algorithms of the same form. All we need to take into account is that an algorithm must have the following characteristics. The first thing we should take note of is that the two centerpieces which were discolored were in a two-cycle with each other, meaning that no other centerpieces were involved in their swap except for them. These two centerpieces are in their own swap, as well as these two and these two. And even all of the setup moves we did to get the Holy Grail algorithm even on the 5x5, we're setting up for 2 cycles. So this is a very important characteristic the algorithm must have. Fortunately, if you follow my methods on how to construct algorithms like these, this will always be the case, so it's really not an issue, but I just thought I should mention it. We can locate the next characteristic of the algorithms by just applying all of this algorithm to a 6x6 cube without the interior setup moves. The problem was we needed interior setup moves to not discolor two centerpieces. We also located the pieces which needed to be affected, and also take note that one of the pieces was right here for this particular algorithm and the other one was right here. The location of both of these pieces are also in the algorithm piece which we're going to use setup moves towards. The piece in the middle, which was 3b prime 3r prime 3b. All the pieces missing indicate what that algorithm affects. And one of the pieces was here and the other piece was here. Even though in the restriction this piece was allowed to be affected because we wanted to fix what was wrong with the cube in the first place, still that piece was in the range of the algorithm piece 3b prime 3r prime 3b. And the last characteristic of the situation we had was that one of them needed to be replaced by that same color that it should be replaced with by the algorithm piece which was in the middle. In our case it was 3b prime 3r prime 3b. And that was true, as I've shown you many times, because When we execute that, this piece right here, which should have been red, is replaced by red by the algorithm piece without any interference whatsoever. This is not always the case for every algorithm. You will still sometimes get algorithms that they have two center pieces swapped like this that are visually discolored, but the algorithm piece does not do this. Listing the 3 characteristics an algorithm must have in order for us to be able to insert interior setup moves to not discolor 2 center pieces which are currently discolored by the entire algorithm are the following. First off, both of the discolored centerpieces need to be in a 2 cycle. Second, both discolored centerpieces are in the range of the interior algorithm piece, and for the Holy Grail example, that was 3B prime 3R prime 3B. And third, one of the 2 discolored centerpieces is replaced by the color it should be by the interior algorithm piece itself, 3B prime 3R prime 3B for the Holy Grail, prior to adding the interior setup moves. And that's basically it. I hope this video series has been helpful and informative to everyone, as well as opening the door for people to start creating their own algorithms of this type, using different commutators and to develop different bases, and shifting of those bases to even get algorithms for other 2 cycle cases, besides just swapping 2 edge pieces within the same composite edge.